Okay, so this is our solving trig equations is no different really to solving just a regular equation, except we are solving for an angle. So for example, and these types of questions are really common, so you will be pretty much guaranteed one. If you have to, let's do solve 2 cos theta minus 1 equals 0 for, we have to give some bounds on what theta has to be. Okay, so we are solving this for theta, okay? We want to find out what angle makes this equation true. And we're saying that the angle has to be between 0 and 2 pi radians, okay? So we're working in radians here. So if this was just a regular equation, 2x minus 1 equals 0, what would be the first thing you would do as somebody from SL? If it was just a regular equation, 2x minus 1 equals 0, what would be the first thing you would do to solve it for x? Yeah, bring the 1 over, add 1 to both sides, so we can do that here. I'm going to add 1 to both sides. That leaves me with 2 cos theta equals 1. And then what would you do if you had 2x equals 1? Yeah, divide both sides by 2. So that means I end up with cos theta equals 1/2. Okay? Now, you're more than likely going to get a question on this in both your paper 1 and your paper 2. In your paper 1, they are going to use your exact values, okay? So, you know, like when we talked about our 60 degrees, 30 degrees, 45 degrees, those kind of values that give us exact numbers out. So looking at this, we're trying to solve this for theta, for the angle. What angle, cos of what angle gives me out a value of 1/2? Is it 60? Let's have a look. So you would go to your triangle, 60, 30, this is 1, 2, this is root 3. Cos of 60, yep, is going to give me adjacent over hypotenuse. So my angle is going to be 60 degrees. Good, Frankie. Now the problem is though, I can't write down 60 degrees because what units am I working in? Yep, so what is 60 degrees in radians? Pi over 3, right, good. Yes. Now, if it was a calculator paper, they're more than likely going to give you one that is not an exact value. So it'll not be something as nice as this. We'll do a calculator one shortly. The calculator ones are actually, they're a little bit easier because you don't need to worry about these exact values. Now, however, we are not done because we know from our cost graph, and this is where you need to take into consideration our cost graph, and we are looking at our cost graph between 0 and 2 pi. Now, just to make this easier, I am going to convert to degrees. So I've got 360, 180, 270. As long as I give my answer, my final answer in radians, that's fine. But in terms of working out any other answers, I am going to use degrees because I find degrees a little bit easier. So we said our first answer was 60 degrees, correct? Pi over 3. Is that okay? So there is 60 degrees. What other value? And that gives me, you know what? These diagrams, let me draw this better. That's a mess. Already not happy with it. No, like it is just a sketch that we're doing, but for the purposes of what we're doing here, I want it to obviously be clear for you. it nice and big. So there's 360, 270, 180, 90. Goes as high as 1, as low as -1. And we're saying, right, 60 is our first answer, so let's say 60 is in here. And that gives me out a value of a half. Okay, what other value is going to give me out a value of a half? Somebody from standard level. Let me figure it out and think. These are our landmarks. What value is going to give me it? Cos of what value is going to give me also a half? Yeah, nice. Was that Darius? Okay, good, because we're 60 is 30 away from 90 in this direction. So if I do exactly the same thing here, 30 away in this direction, brings me up to 300. Or you could think of it as 60 from 0, 60 back from 360. So our other answer is 300 degrees. Now I can't write 300 degrees because I have to give it in radians. How can I change 300 degrees into radians? What do I multiply it by? Or how can I work out what's the how can I work out what 300 degrees is in radians? Yeah, you can multiply by pi over 180. And then I'm going to simplify this. So let's see, 3 goes into 180 60 times, 3 goes into 300 100 times. I can simplify it again. 10 pi over 6, 5 pi over 3. So that is another answer. So you may get more than one answer. More than likely, you will, okay? And it all depends on the range for the angle that we are given, okay? We're told that the angle has to be between 0 and 360, or 2 pi. So it's only going to be this value and this value. How are we thinking? Is that okay? Yeah? Okay, cool. Shall we do one more? Nasty. Okay, let's do this next one. Because this is another common one. If I move that down to there, is that okay? Okay, so remember I am recording, so you can always watch back if necessary. So this one we're going to solve minus 2 cos squared theta minus sine theta plus 1 equals 0. And this time we're going to do it between theta and 4 pi. So first off, if we have something like this, if you ever have got... Actually, you know what? We haven't done this bit before. So let's scrap this example. Marco, you should be able to do that, though. Well, yes, because we're dealing with cos squared here. Something we haven't looked at yet in standard level, so we will come back to this, okay? So just hold off on this one just for the moment. Okay. Do you guys have your textbooks handy there? So page 519 is where you're going to have a look at this. I'm just going to kind of give you just to kind of show you, the first couple of questions here are, you would use your calculator. If it ever asks you to give it to 1 decimal place or anything like that, you would use your calculator. So the first thing you're going to look at is, we're going to solve cos of theta. This is the question 1a is equal to 0.6, and we're doing it between 0 and 360. So this is nice, we're working in degrees. And how could we work out, what operation do we have to use if we want to find out what theta is? Yeah, inverse cosine. And the calculator will do this for you. So can you see my calculator? And we want to make sure that, so I'm currently working in degrees with this question. So can you see my calculator screen? Just to check. Cool. So oh, right, okay. So I've got inverse cos of 0.6, and that gives me out an answer of 53.1 degrees, and we want it to one decimal place, so 53.1. 53.1 degrees. And obviously we need to check whether there are other answers. So you have to draw out your cos curve. And remember, it's just a sketch. 360, 180, 270, 90, 53.1 is in here somewhere. 53.1 is how far from 90? My calculator, so 90, take away 53.1, it's 36.9. So this is 36.9, so I want to go 36.9 in this direction from 270, which is going to give me 306.9. Okay, because that's going to give me the same answer. So my two answers are 53.1 and 306.9. So it's exactly the same as before, except we're not looking at exact values. Okay, we've got decimal answers. Does that make sense? What about the rest of us? Cool. Do you think you'd be able to have a go at question 1 and question 2? Cool. Have a look at question 1, question 2. You have to draw these out, okay? You have to draw them to make sure that you get all the answers. If you just write down 53.1, you're going to miss a couple of marks, okay? So you have to make sure you draw them out to make sure that you get all the answers. Have a look at question 1 and question 2 and get back to me if you have any problems, okay? So let me just pause recording for a second. I'm going to just record for Ari and Jaden as well. So let me just write a couple of these out. So the first thing that we'd shown this one in class. Plus cos sine b. And then you'd shown that's minus sine b. Okay, and then question 3 says, given the identity, tan theta equals sine theta over cos theta. Okay, so that implies that show that tan A plus B equals tan A plus tan B over minus tan A tan B. Okay, let's see how we get on with this. Right, so first off, we're going to start with tan A plus B. And we're told in the question, well, that's going to be sine A plus B over cos A plus B. All right. Next thing I'm going to do is I'm going to use my formulas and I'm going to substitute those into here. Does that make sense? Cool. So I am just playing about with this. I have no idea whether this is going to work or not, but I'm kind of figuring this is the only thing I can really do at the minute. So let's just do it and hope for the best. All right. Okay, now what do you think, Marco? You mean set it equal to this tan A plus? It's not a bad thing to do just for practice, just to kind of for yourself. But in the exam, you wouldn't be able to do that. You have to kind of just start with this side and work until you get to the other side. Your kind of clue here is look at what you're trying to get to. You can see my cursor, okay? Yeah, is that okay? So the thing that I'm noticing here is I've got a 1 here, and I've got a cos A, cos B here. How could I turn this cos A, cos B into a 1? What would I divide by? Yeah, if I divide every single term in this, if I divide every term by cos A, cos B, I'm going to divide that by it, I'm going to divide that by it, and this by it, divide by cos A, cos B, divide this term by it. So I'm dividing everything by the same thing, so I'm not changing it. Let's see what we get. So I'll write it out. So sine A cos B over cos A cos B plus cos A sine B over cos A cos B. So that's the top line, okay? And the bottom line, got my cos A cos B divided by cos A cos B, which is just 1. And then I've got sine A sine B over cos A cos B. And then this is looking nice because I know that sine over cos is tan. This cos and this cos are going to cancel. This cos A and this cos A are going to cancel. What else? Yeah, can't do anything there. Yep, so I've got tan A and tan B on top, so that works, that's nice. Over, I've got the 1, and then I've got sine A over cos A, which is tan A, and that's multiplied by sine B over cos B, which is tan B. It's the kind of noticing, like, always kind of keep an eye on what you're trying to get to and see if you can spot anything that's going to help. It was realizing, okay, if I divide this by the same thing, I'm going to get 1. And if I divide everything else by it as well, I'm going to end up with a whole pile of tans because I'm dividing by cos. Hopefully that helps. No worries. Yeah, there will always be a way. Was there any of those other ones? Okay. Yeah. Um, I would definitely have a look at the, like, question 6 is really good. Those are really kind of common. Like, those prove those identities. Um, definitely have a go at those because those are pretty tricky. Okay. And if you have any other questions or anything like that, you can just give me a shout.